We're going to talk today about how to name acid salts and how to convert acid salt formulas into names. So I want you to consider H2SO4, AQ. So this is not a salt, it's a neutral compound. In fact, this compound is referred to as an acid because it has hydrogen and it's dissolved in water. When hydrogen-containing compounds are dissolved in water, they exhibit acidic properties. You'll learn more about that later on in the course. For now, we just want to talk about how to name this. Well, we learned in the last video that you would change the ATE ending of sulfate to ic, so this would be named as sulfuric acid. So notice that I have two hydrogens here, which makes this whole thing neutral, because a sulfate ion on its own has a -2 charge, and hydrogens contribute +1. Two hydrogens at +1 make an overall +2 charge, and the positive 2 is balancing that -2, so this is a neutral compound. I can, however, create a polyatomic that contains hydrogen, a polyatomic ion rather that contains hydrogen, by not giving it two hydrogens. So supposing I had this particular entity, HSO4. Well, this carries a charge. Let's find out what it is. Sulfate on its own is -2. Recall that hydrogen contributes +1. If I have one of these at +1 and one of those at -2, this entire entity would carry a -1 charge. Just think of it this way. Take whatever sulfates is, which you know and have memorized, drop it by 1 if you see one hydrogen. You would drop it by 2 if you saw two hydrogens, which would go down to 0 and make it neutral, as we saw earlier. But this has got a charge of -1, and that's a charge we're interested in. Because it's got a -1 charge, or a charge at all, a negative charge in fact, it can bond with a metal ionically, and we can create a salt. A salt is an ionic compound formed when you have a metal reacting with a nonmetal or a group of nonmetals, as we have here. So if I took magnesium and I bonded it with this, magnesium is in group 2, so its charge is +2. I would cross that down following the crisscross rule. You cross down the 1. The 1 is understood, so I don't really need it there. And I'm going to erase these charges. And so we have a neutral salt. We would call this an acid salt because it does have hydrogen. But just because it's an acid salt doesn't mean we give it an acid name like we did before, sulfuric acid. It's not going to have the word acid in its name. So how do we name it then? You're going to name the elements you see, starting with magnesium. This is hydrogen, so we're going to write hydrogen. And this, you know, this is a polyatomic ion sulfate, so this is going to be called magnesium hydrogen sulfate. And that's it. That's how you name it. So let's make it a little more complicated, and let's use a different polyatomic ion and a different metal. So let's say we wanted to make one with tin. And let's say I did this. Okay. So in this case, this isn't a polyatomic ion in here. It's just a simple nonmetal. So this would have an IDE ending. So how do we name this? Well, tin is multivalent, so we have to specify its valence. Always use the negative to find the positive. So sulfur is -2 normally, but remember the hydrogen will drop this 2 by 1, so this is overall -1. 2 of these at -1 provides a total negative charge of -2. If I have one tin, it must be therefore +2. So this would be referred to as tin 2, hydrogen. Remember, just name the element you see, hydrogen sulfide. Notice that no prefixes are used here. It's not monohydrogen. We just say tin 2, hydrogen sulfide. Okay, so what happens when we have something that contains phosphorus? Phosphorus has a -3 charge. So you can actually create two ions with phosphorus, or in the same way that we can do it with just the element phosphorus, we can do this with phosphate. So let's do it with phosphate also. So if I use phosphorus and give it one hydrogen, what would the charge on this polyatomic be? Well, remember phosphorus is normally -3. Drop the charge by 1 with every one hydrogen, so this thing would be -2. If I gave it two hydrogens, then this would also carry a charge. What would the charge on this this ion B, -3, drop it by 2, overall -1. So you can create two types of compounds with these. So for example, or two different compounds. If I took sodium, for instance, then applying the crisscross rule with that 2, the 2 comes down, and I'd end up with, and sodium has a charge of 1, so that would cross down there and I could erase it. So I'd end up with Na2HP. The brackets are optional when you have only one of that ion. Here we have sodium as well. We can put sodium with this particular ion. And we cross that down. Sodium is 1, that's 1, so they would crisscross and erase. So how do I name these? Well, I can't name them as I did before because then they'd end up with the same name. Sodium hydrogen phosphide, sodium hydrogen phosphide. We need to be able to distinguish these two, and we're going to use a prefix. This is the one time a prefix is allowed to indicate the difference between these two ions. So this would be sodium hydrogen phosphide, IDE because it's just a simple element, a single element and not a polyatomic. Sodium dihydrogen phosphide. Okay, so but what about if we had phosphate? Well, the same thing applies. If I wanted to make H2PO4, oh, sorry, is that? Well, this would carry a charge. Phosphate is -3, take away 2, -1 overall. If I added another hydrogen, then I'd have a neutral compound, and we wouldn't name it. It wouldn't bond ionically to anything because it's neutral. Why would it bond to a metal ionically? It wouldn't attract a metal ion. It would be it wouldn't have a charge, so it wouldn't attract. So you wouldn't be naming that like that. It would follow the acid naming rules we saw before. So if I only give it one hydrogen, I could create this polyatomic ion. It would have a -2 charge here. My apologies. So think phosphate -3, take away 1 for the hydrogen, you're down to -2. So -2 charge means it can bond to a metal. -1 can bond to a metal. So if I take, for instance, let's do lithium. Lithium, like sodium, has a +1 charge. That would cross down there. This would cross here. This would be lithium hydrogen phosphate. And then you can erase the charges. Here, in this case, let's say I took it and I used iron, for instance. Well, iron has a charge of +2 or +3. Let's use the one that has a charge of +3. The 3 comes down, the 1 goes there, so I don't need to write it. So this would be called iron 3 dihydrogen phosphate. Now, you can take away oxygens and create other polyatomic ions similar to the ones we've just been speaking about and bond those to metals. So let's say we had, for instance, this compound to name. Actually, pardon me, let's do, okay. So this is manganese. We have to find its valence because it's multivalent. Let's do that by working with the charge on the anion and then figuring out the charge on the cation here. So phosphate, this is not phosphate, but it's related to phosphate. It has 2 less oxygens than phosphate. So this would be hypophosphite. So in any case, they both have the same charge, which would be -3. Drop it by 1 because we have that hydrogen. This whole entity has a -2 charge. 2 of them at -2 make a total of -4. With 1 manganese, it must be carrying a full +4, otherwise this compound is not neutral. So this is manganese 4, and what do we call this? Hydrogen, not dihydrogen because there's only one. Hydrogen hypophosphite. Hydrogen hypophosphite. Okay. Now, I saw a lot of students when they were naming these on the ISA demo with a 3 here. I realized they did that because they were crossing the charge on hypophosphite down. But then that would make a neutral compound. There's no way that would ever bond to a metal. So remember that if you're looking at the name and you're asked to convert to the formula, it will tell you how many hydrogens there are. If it says hydrogen, there's only 1. No need to write a subscript here. And that'll be followed by whatever polyatomic ion is here. In most cases, it's only one hydrogen. It's just when phosphorus is involved that we have the possibility of having a polyatomic that contains one hydrogen or a polyatomic ion that contains two hydrogens. In most other cases, it's just a single hydrogen. And the name will say hydrogen. That's how you know there's only one of them. So let's go backwards and try that. We'll do one more example. So for instance, if you had to name ferric, let's do ferric ortho. Oh, sorry, I forgot the hydrogen. Ferric hydrogen, ortho, arsenite, let's do. Okay, this is a tricky polyatomic here, but I'll show you how to figure it out. So ferric is iron, so we start by writing iron. Ic tells us it's the higher of the two possible valences for iron, so that's +3. Next we have a hydrogen in there, and then we have this thing, orthoarsenite. The trick to remembering which one this is MnOP. So meta is like the nitrate, ortho is like the phosphate. So if it's like phosphate, then I know that it would have a charge of -3 normally. Because it's ite, then it would drop one oxygen from phosphate. So phosphate is normally PO4 -3. So this would be just like phosphate. If it was arsenate, it would be AsO4 -3. Same number of oxygens, same charge, different element. Arsenic in place of phosphorus. But because it's the ite, it's one less O than what the phosphorus would be. So PO4 becomes PO3, or in this case, ASO3. The charge on this is normally -3. Drop up by 1 because of that one hydrogen. So it carries a charge of -2. So now we're going to cross those charges. So the 2 comes down here, and the 3 comes there. So there you have ferric, hydrogen, orthoarsenite. Okay, that's it.